In this lecture, we will cover the application of dependent sample t-test in SPSS. The independent sample t-test basically when we obtain, why we are actually calling that it variable, the t-test is called as paired or dependent because we are obtaining the two observation from each participant. Like when we are encountering the case of the before after, for example, the way to compare the weight before and after the exercise. So here we go, the before observation and the after observation are paired because we are obtaining paired observation from single participant. So this is the paired, this is why it is called as the paired sample t-test. Another reason for the dependent sample, it is because the after observation depends on the before after observation. That is why we call them dependent sample. We have different example of the independent sample test. One is that comparing the blood pressure at the standing and the supine condition. So the we are obtaining the two observation. One is standing and supine from the same person. That is why it is called a pair sample. And comparing the weight before and after the treatment. For example, comparing the family stress of score from two sisters of same family. The family is one, and we are, let's suppose, taking the data of 100 families. So from each family, we are obtaining the paired observation that is from the two sisters. Comparing two instructor in a teaching evaluation score from the student of same class. So the class will be the same, and we are asking to fill them evaluation form for the two instructors. So teacher, the student are same while the observation are two for them. We will discuss the example for the application of the peer sample teachers using SPSS is that, for example, a hospital management wants to observe if there is a significant change in the triglyceride values of the telephone operator randomly chosen from 10 departments. And for these are the triglyceride values in millimole per liter before and after their recruitment. We had to test the hypothesis that was there any significant difference in triglyceride value before and after joining the job as telephone operator in the hospital. So what we have the 10 observation, like 10 telephone operators, and their uh, triglyceride level were observed before the recruitment and after the recruitment. So paired sample t-test is again concerned with the continuous variable. So we have any, whenever we have any quantitative or we say continuous variable, we have to check the normality first. The data is entered in this file, like we have two variable, one is before, another one is after, and before and after variables are entered this way. So we have 10 observation of 10 telephone operators. First, we will check the normality using the option Analyze and Descriptive Statistics, and then we will go to Explore. In the Explore, we will put both before and after in the dependent list because both are continuous variable and both are to be checked for normality. So we will then click the option Plots. In the plots, we have the normality plot with test. We will click on it. We'll press Continue. I will press OK. In the output file, SPSS will display many tables. Our concern is with the table which has test of normality. It shows the p-value for the two tests. One is Kolmogosov, another one is Shapiro-Wilk test. Since we have the small sample size, we will use this Shapiro-Wilk test, and with the assumption that if p-value will be more than 0.05, then our data will follow the normal distribution. So since both p-values in this scenario is more than 0.05, so it gives us a green signal to apply the paired sample t-test. So our so we have to then again make the statement of 6 steps. First step is statement of hypothesis. One is null hypothesis, another one is alternative hypothesis. Null hypothesis contains the equality, and the alternative hypothesis does not contain, is just a contradictory to null hypothesis. So in our case, the null hypothesis will be the mean triglyceride level of the telephone operator before and after the recruitment is same, and the mean triglyceride level before and after are different. Level of significance alpha is equal to 0.05 because it is not specifically defined in the question. And test strategy we will use is paired sample C test, and the rejection region will be reject the null hypothesis if p-value is less than equal to alpha. Then we will use the computation and then we will go to the result and conclusion. We have the data, the computation is like, and we will go to analyze, compare mean and the pair sample t-test. In the pair sample t-test, a dialog box will appear. We have to provide the variable value like after the recruitment and the before the recruitment. And we'll press OK, and after that, this output will appear. I mean, the three table will appear. Our major concern is with the pair sample t, the table of the pair sample t-test. The sig is the p-value which shows 0.000, which is implied that the p-value is less than 0.001. Actually, we do not write the p-value as exactly 0.000 because it's a probability, and probability can never be exactly equal to 0. So that is why when we are writing, in fact, this is due to because the software displays up to 3 decimal places, but that is why, because otherwise the p-value cannot be exactly 0. So our conclusion is that the p-value is less than 0.001, which is also less than 0.00 alpha, our alpha value, which is 0.05. Therefore, we accept an alternative hypothesis, and we reject an alternative hypothesis, and we conclude that there was a significant difference in the triglyceride value of the telephone operator before and after their recruitment in the hospital as telephone operators. Thank you.